It's recording. All right, year 11s. Before we start the next exercise 5H, I was going through the notes yesterday and I just felt like maybe I went a bit too theoretical for you guys. And I just wanted to revise just what we did in 5G, inverse functions, and what you need to know at a sort of a fluency level, at a just how to do things. That's all I want you to know. But if you did understand the things I said yesterday, then I did chuck in some year 12 methods examples just to help you see how we use that same idea and what they're doing slightly different. But it's pretty much the same thing. Yeah. So in a nutshell, if yesterday's lesson got a bit too overwhelming because I did a bit of revision on chapter 5, what a function is, what a relation is, this is what this video is going to be. Okay, it's very short. There was only two things I wanted you to understand yesterday from inverses. So again, let's recap. 5G. Inverse functions. There's only two things that you must understand. Number one, for an inverse function to exist, meaning that you can work out an inverse function, because the key word is function there. So inverse function exists if and only if, what was it again? That's right, the original function. So if they gave you a function, the function that they give you must be a one-to-one. If it's not a one-to-one function, you cannot get an inverse function. Okay? So that is the first thing that you need to understand. So how do you know if something is a one-to-one function? What was the test that you can do to know if it's a one-to-one? Yes. Good. Use horizontal line test to test if it is a one-to-one. Vertical line test is to test what? What does a vertical line test do? You test this, Molly? Very good. It's a function or not. But yes, it also tests if it's a relation. Because if it's not a function, then it's a relation. Okay, so if you do a vertical line test, crosses twice, that's a relation. Crosses once, it's a function. All right? So that was the first thing that you needed to know. Number two is the how. The number two is the how, and that's pretty much what 5G is. And I'll do one example right after this one so you can see there's only two things you needed to know. The second point was that you know that once the inverse function does exist, then the domain of the original function is equivalent to the range of the inverse. Very good. Because it all swaps around. So the x becomes the y, and then same thing, the range of the function then becomes the domain of the inverse. So the y becomes the x. Okay, everything swaps around. So essentially, the how component in exercise 5G, all you needed to understand was that for every xy coordinate, you are swapping the x and the y. So here's an example. So from exercise 5G, here's an example so you can see. When they say, for example, this one, I'm just going to pick question 4a. They say find the inverse function of each of the following. What you need to do, the how component, is literally this. So what's the function? That's root 16 minus x squared. All right, so I'm just doing an example here. Question 4a from exercise 5G. You got f of x is equal to the square root of 16 minus x squared, right? Then if you want to find the inverse function, usually you have to test that this is actually, that it actually exists to begin with, but let's assume it does. Then here's the how. The how is that you're going to swap the x and the y's. So here, this is how you start off. You say, since that's f of x, it's a bit confusing. You can make it equal to y. So you let y equal to f of x. You have to tell the examiners that's what you're doing. Your equation now becomes y equals root of 16 minus x squared. And if you want to find the inverse function, this is how you find it. To find inverse we essentially are doing f of y equals x, which is the notes I gave to you yesterday, or in layman terms, swap the x and y's. Y becomes x, x becomes y. So that means this y is now an x, and that x squared now becomes y squared. Does that make sense? So this is the how. So if yesterday I confused you with the theoretical component, this is all I needed you to know at year 11 to begin with. If you can understand it deeper, then it helps you to understand what chapter 5 is really about. But that's the method. So here you're just swapping x now is y, so y equals x and x equals y. So now to find the inverse function, you just need to rearrange that equation to get y by itself. So here we go. To get y by itself, I need to get rid of the square, the minus, the 16, and the square root. So doing the inverse of BODMAS, getting rid of the square root. What's the inverse of square rooting? Square. So here I say square both sides. Square root and the square cancels out. Now you have x squared on the left, 16 is left over, minus y squared. Inverse of BODMAS, so get rid of the 16. How do I get rid of 16? Let's go with Luke. Very good. So here we would minus 16, because positive 16 minus 16 cancels out. You end up with negative y squared is equal to x squared minus 16. Get rid of the negative. How do I get rid of the negative? Let's go with Artie. I've got a negative in front of the y squared. How do I get rid of that? Yeah, that's the easiest way. You can divide it by -1 or times by -1, doesn't matter. So times -1 to that, times this by -1. Since there are two terms, make sure to times -1 to both sides. So this gives you negative of x squared. This is plus 16, and this is equal to y squared. Your goal is to get y. I don't want the square, so what's the inverse of squaring? Square rooting. So here we say square root. Squares and square roots cancel out. So y, which remember that was the inverse function, because I made up the letter y. I said let y equal to the inverse function. It is the root of, and I normally like to write it this way instead, but it doesn't matter. You can write negative x squared plus 16, or this just looks nicer, neater. This is my inverse function. But remember, when you square root, what's the one thing you have to be careful of? Plus minus. And this is where most year 12s miss out. Because at year 12, getting up to this point, that's 1 mark. But knowing that which one is the correct answer. Is it a positive root or is it a negative root? Because it matters. Because remember, it's a function, not a relation. And a square root function only has a top half and a bottom half. So you have to choose which one's correct. And how do you know? Well, remember what I taught you just now. I said the how was you did the swap. You've got the function. You just don't know whether it's plus or minus. You have to use this property. The domain of the function, the original one, is equal to the range of the inverse, or the range of the original is equal to the domain of the inverse. You've got to find which one fits that property. Now, if you look back at the equation for exercise 4a, they already told you. They told you that the domain of the original function, which is this one, that graph, the domain is 0 to 4. But if that's true, that means that the range of the inverse must also equal to the domain of the function. So that means the range can only be between 0 to 4. So out of those two, which one, the plus or the minus, will have the range of the inverse equal to 0 to 4? And this goes back to chapter 4. Okay, so do you know what type of graph this is? Anyone know? What type of graph is this one? Looks like a square root, but it's not a square root. It is a semicircle, okay, because of that square. Had there not been that square, this would have been a square root, and it would have moved to the right by 16. But this one is actually a semicircle. So the question is, which semicircle, the top half or the bottom half, will make sense that the range has to be 0 to 4. Is it the top half or the bottom half? Top half. So that means the answer, the F inverse, and if you write it properly, you should be writing function notation. So you're telling what letter you're using. So F inverse, write the domain, which we don't know what the domain is the moment unless you sketch that. So I'm just going to put a blank for now. F inverse of x is equal to, and it has to be the positive root of 16 minus x squared. This is the how. And that's the proper way in year 12. You do have to write the domain. It means you have to know how to sketch the semicircle. Now, out of curiosity, the semicircle, what's the radius? What's a semicircle for this radius? 4, because there's that's my r squared. So just recapping from chapter 4, that's radius of 4. That's -4, that's 4. We already know the range is 0 to 4, so that's true. It's the top half. Range is correct. So what's the domain? What's the domain? I've just sketched it for you. What's the domain of this semicircle? Semicircle's drawn over here. What's the domain? Yeah. So -4 to 4. This is what they expect you to be able to do by the end of the year or starting year 12. That's what my year 12s have to do from now on. Okay, so every time they ask for the inverse function at the end of year 12 exam, they need to, it's a 2-marker. You have to have the inverse function and you have to have the domain. This is called a function notation. Okay, so in one sentence, people can tell what's your domain. You can figure out the range if you know the graph. Okay, that's why you always have to write the domain. Okay, but at your level, I don't mind where you're sort of sitting at. At the moment, I thought yesterday might have been too confusing, so I thought I'd summarize today. First one is it has to be a one-to-one function for an inverse to exist. That's point number 1. Point number 2 that you needed to understand, which is 5G practice, this is the how. Domain of the original becomes the range of the inverse because we're swapping the x and the y's, and this is the how. That's what you're practicing with 5G. Okay, so hopefully that gives you a bit more to bite on instead of yesterday. If the theoretical part was too much, that's what you need to be able to do. Swap the x and y's, rearrange algebraically, and then the tough part is making sure if there is the square root version, you gotta decide which one it is, plus or minus. Most of it won't be. Most of the questions that you practice here are linear. See how it's linear? There is no square root, no square root, no square root, no square root, no square root. There will be a square root here, no square root, no square root. Also, there will be a square root there. Okay, so you start to find these inverses as you do in the first 2 questions. They're going to be pretty easy. Once you start doing the square roots, be careful because it does matter which one, whether it's a plus or a minus. And that's why question 4, the one I chose, was a nice one. Okay. And then similarly, as you get further down, then they just do a bit more, but that's 5G. Is that a better feeling than yesterday's lesson? Okay, but I've just recorded that, so if you want to watch again, that's there. But if you want to see what the year 12s do, I've done the example videos there. It's pretty much what we just did. Okay, so if you want to see more of those type of examples, there's like 6 videos there. Okay. All right, so I'm going to stop this one now, and for today's exercise, pretty quick and easy. It's just applications, and you'll find it's very similar to the SAC, and it is practicing the CAS. So that's what I mean. If you keep sticking to it, have a thick skin, stick to it for the next 6 months, you'll see the skills that I'm teaching you is repetitive, and you just get better at it in the next 6 months. Okay, so we've just got to do that. So here we go. I'm going to stop the video.